guys, and welcome to Smart Hub. Okay, so in today's lesson we are introducing a new topic, and that is dimensional analysis. I know to some of you it's a new topic, some of you've heard about it before, but don't worry, you are going to know it, or let me say today you are knowing it. Okay, so without wasting much of the time, first you have to know what dimensional analysis is. Okay, so this is the method in physics. It is used in physics, chemistry, and mathematics, but in this case, let's say it is used in physics to solve problems by looking at the units or dimensions of quantities involved. Okay, so it's the method. So dimensional analysis is the method used to solve problems. Okay, solve problems by looking at the units or dimensions. Okay, so now next thing, you have to know the uses of dimensional analysis. Okay, so dimensional analysis, one, it helps us to check if the equation is correct. Okay, so to check if the equation is correct. The next, we can use it to convert units. Used to convert units and to solve problems when formulas are not known. Even understanding the relationship between quantities. Relationship between quantities. Okay, so these are just some of the uses of dimensional analysis. The rest, you're going to look for them by yourselves. Okay, yeah. Okay, so our aim is to make things easy for you and to make you pass the test and the exams. Okay, so we are not going to be giving you irrelevant stuffs, but things that can make you pass the test as well as the exams. So now let's now talk about how the questions are brought. Mostly, or let me say always, questions are brought from these two. Checking if they, okay, yeah, even this one, checking if the equation is correct, to convert units, yeah, changing from one unit to another. even understanding the relationship between quantities. So we're going to start with this one, to convert units. Okay, so converting units. So how do we use dimension analysis to convert units? Okay, so let's say for example, you are told to convert 80 kilometers per hour to meters per seconds. Okay, so you are converting from kilometers per hour to meters per seconds. Okay, so it's different from the way we were doing it secondary. Okay, so let's see how we can convert this one. Yeah, so first thing first, you have to recall. You ask yourself, 1 kilometer, let me write from here, 1 kilometer is equivalent to 1000 meters. Okay, then 1 hour is equivalent to 60 minutes. Then 1 minute is equal to 60 seconds. Okay, so we are converting to meters per seconds. Okay, so how do we go about this one? Okay, so after recalling this, you recall this. Now you get the figure given. You've been given 80 kilometers per hour. So this simply means that it's 80 kilometer over an hour. So you say 80 kilometers per hour. Then you start by converting. You start by converting time. Okay, so you have distance and time. So you first start with this with time. You say 1 hour is equal to 60 minutes. So you write hour on top. The m is to cancel with this one. Okay, so 1 hour is equivalent to how many minutes? 60 minutes. You close, meaning this one is going to cancel with this one. So 60 minutes. You open again. We don't want hours. We don't want minutes. We want seconds. So we are breaking it step by step without skipping any unit. So these are unit conversions. Then you say 1 minute is equivalent to how many seconds? We said 60 seconds. You write 60 seconds here. You close. Okay, then so now if this one cancels with this one and this one cancels with this one, we are remaining with what? Seconds. Yeah, we are looking for seconds, right? So we are done with time. Now we can go to distance. Okay, you want these kilometers to be in meters. So how are we going to break it? We said 1 kilometer, say 1 kilometer. So kilometer is on top, so here it is going to be at the bottom. The aim is to make them cancel, so one has to be down, then the other one on top. Yeah, one on top, one has to be down. Okay, so you're going to say 1000 meters is equivalent to 1 kilometer. That's all. Meaning this kilometer is going to cancel with this one. We are going to remain with it. Let me now rewrite what we've remained with so that things become simple. So we've remained with 8. This one has disappeared, even this one. What have we remained with? So you multiply everything on top. We are going to have 80,000 on top. 80,000 meters over what else? At the bottom, you multiply everything here. 60 times 60. We are going to have 3. I mean, should be 36 seconds. Okay. Then this into this, you're going to get 22, something like this, 22.22. Okay, so I'm just going to write 1. Okay, so even the units, so we've remained with meters and seconds. So meters per seconds. Okay, meters per seconds, like this. So this is how we convert this is how we convert units from one unit to the other. So next we are going to then the next one, the one we talked about, the understanding the relationship between quantities. So how do we go about this one? Okay, let's see. Okay, so number 2, talking about driving relationships. Between, or let me say among, because sometimes you can drive quantities more than 2 quantities. So let's say among quantities. To check if an expression is dimensionally constant, homogeneity. Okay, so when it comes to this one, there are some limitations. Okay, so let's talk about the limitations. Some of the limitations of dimension analysis. Yes, so what are some of the limitations? So we have this one saying dimension analysis is only applicable to 3 dimensions. This one, the very important one. So dimension analysis is only applicable to 3 dimensions. Okay, so the dimensions are physical nature of a quantity. Okay, so what are these 3? What are these only 3? So we have one, length. We have length. 2, we have mass. 3, we have time. Okay, then the units, the symbols. For time we use T, capital letter T. For mass we use capital letter M. Then for length we use capital letter L when it comes to dimension analysis. The second one does not give the value of constant K. Does not give the value of constant K. You understand this when we start answering, then or when you go through the notes. We've uploaded some notes on the website. Okay, then the third one, not applicable to logarithmic. Okay, so not applicable to logarithmic logs, logarithmic exponential, what else? And the trigonometric functions and the trig. Okay, it is not applicable to this. Let's look at some of the rules. The rules we follow. Okay, so you can let me just talk about one rule. You can only add or subtract items with the same dimensions. You can only subtract or add items with the same dimensions. Okay, so now let's quickly talk about the steps we follow when we are driving. We are deriving relationships among quantities. So this one is very important. So all you have to do is to pay attention. So let's talk about the steps we follow. Okay, so for you to understand very well the steps, it's very simple to understand using an example. So let's pick an example. So derive the expression for acceleration if it is related to the velocity. Okay, so example, derive the expression the expression. Okay, so here is an example. Drive the expression for acceleration if it is related to the velocity v and the radius r. Okay, so the first thing, I drive the expression for acceleration if it is related to the velocity v and the radius. So you have to write this expression in what can I say, in symbols. Okay, so we have acceleration. What's a symbol for acceleration? So acceleration, we use small letter a, then velocity, you've been given v. So here they are saying related. So there is a symbol we use, the alpha or proportionality symbol that that we use when you're talking about relation. Okay, so related to the velocity v and the radius, like this. Okay, so acceleration, if it is related to the velocity, so related to the velocity and the radius r. So this is the interpretation. So you interpret this using symbols of the quantities given. Then to the given quantities, you indicate the letters. We don't know the powers, so we are just going to randomly pick any letters we put on top of these two. So let's use x and y, because the powers of these are unknown. Okay, so step number two, you replace each quantity, you replace the proportionality symbol proportionality symbol. We're talking about this one. You replace it with the equal sign, and k, the constant. Yeah, so this is step number two. So step number two goes like this. You replace with equal sign, so is equal to k v to the power x dot r to the power y. These are still unknown. Okay, so let's go to step number three. So step number three, you replace each quantity with its SI units. Okay, you replace with its SI units. That's step number three. Make sure you know these. Yeah, it's one of the very important topics in physics at your level. So you ask yourself, what are the units of acceleration? So acceleration is equal to meters per second squared. What about velocity? Velocity is equal to meters per second. When we are talking about radius, we're talking about distance. So here it's in radius, it's meters. Distance is measured in meters. Okay, this is the SI unit for distance. Yeah, so we are saying replace. So we are going to replace where there is acceleration, we replace with meters per seconds. Say meters per second squared is equal to, k is a constant, still unknown. Like we said, dimension analysis does not give the value of the constant k. Okay, so you open the brackets, velocity meters per seconds, don't forget the power x, you again open radius meters, don't forget the power y. Let's hope we are following. Yeah, so let's go to step number 4. So step number 4, we put the appropriate dimensions for each unit. Remember we talked about the dimensions. We talked about mass, length, and time. Okay, so now step number 4 is about putting the appropriate dimensions for each unit. Okay, so we said this is mass, this is length, and this is time. Okay, so here we have meters. Meters, we're talking about length. So we're going to say length over this is, these are seconds, we're talking about time. So you replace with t. Don't forget the power 2 is equal to constant. You open, we have meters. This is length. We have time to the power x. So here we're going to have x even here. We're going to have x. Then we also have this meters. This is length to the power y. Okay. So step number 5. Let's go to step number 5. What about step number 5? Step number 5, we turn denominators to denominators. I mean, we turn denominators to numerators. So denominators to numerators. So how do we go about this one? Remember, when you are turning denominators to numerators, that denominator becomes, if it's positive, it's going to become negative. If it's negative, it's going to become positive, and vice versa. So we have length this denominator is going to become a numerator, meaning the power, the sign of the power is going to change. It is positive 2, so on top it's going to become to the power negative 2 is equal to constant length to the power x. This denominator is going to become the numerator. So this x again is going to become negative x, like that. Then we also have length here to the power y. As simple as that. Okay, what's next? Let's go to step number 6. So step number 6, we equate now the powers. equate the powers. Okay, so we have this one, this one, this one, this one. What about this one? What are we going to do about this one? So if it has no power, meaning it has a 1 here, remember, we don't just write ones, because then the 1 has no impact on any number. Any number to the power 1, there will be no change. That's why it is left. But let me just include it here so that we equate well. Okay, so we have 1 is equal to 1 is equal to, so we're going to start with L's. Okay, so here we have L, length. So we have 3 lengths. We are going to equate the powers of lengths. So we have first 1 here to the left side of the equal sign is equal to, we also have this L, X. So here you add. Okay, so X plus you add what's on the left side, you equate to the ones to the right hand side, to the right side of the equal sign. You add them, then you equate them to the left side of the equal sign. So x plus y. Okay, so this is more like our equation 1. So let's also equate the one for time. So for time we have this one, we also have this one, only 2. So we have negative 2 here, we equate it to negative x. Okay, so this one we can solve this one. So we're just going to cancel the negative, then x is going to be equal to 2. As simple as that. So now, since we know the value of x, we are just going to replace here. We are going to say, you replace x with 2 plus y. Then y is equal to negative 1. So we've found the values of x and y. Remember where we came from? We were looking for the values of x and y. That's how this procedure all about, is to find the values of x and y. But we've remained with one step. Remember, we are looking for the relationship. Okay, so we've found the values of the powers. So now what's next? Okay, so remember, we are doing replace the letters of, so step number 7, replace the letters of A is equal to k velocity to the power x r to the power y with x is equal to, we found 2, then y is equal to negative 1. Okay, so we are going to have acceleration is equal to constant v to the power x is equal to 2, so we replace with 2, then r to the power negative 1. So remember, this is having the power negative it's r to the power negative, so it's going to become our denominator, so that it becomes it's to the power negative, so we are going to turn it to it's going to be our denominator, so that the power changes to positive. Okay, so acceleration is finally acceleration is equal to kv to the power 2 over r positive. So this is the relationship. So in the next lesson, we are going to answer more examples, and especially questions from tests and the exam past paper questions. Thank you for watching. See you in the next lesson.